Okay, we're going to be covering something called noble gas configuration. So it's kind of just coming off of what we left off the other day. On your little tool here for shorthand configuration, we're going to add another part for the noble gas configuration. So this very rightmost column here, this family or this section of elements here are called the noble gases. They're very stable atoms that have stable electron configurations. So go ahead and write noble gases above it. We do include helium over here. I know the other day we had helium over here, but helium technically is a noble gas, and we're going to be referencing it today as a noble gas. Okay, so just like the other day, we were talking about doing electron configuration, going like to calcium, for example. We went from 1s, the first energy level, to calcium. We gave all these instructions: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So this is kind of like how if you were giving directions from your house to a friend's house, going directly from your friend's house to your house, you would give all the street names and like make a left here, make a right, including every single street that they'd have to go travel on. However, a shorter way to maybe give directions is referencing a landmark that's kind of in between your house and your friend's house. So for example, maybe referencing, oh, well, from the Portillos on Lake Street, that's near Bloomingdale Road, you would, from Lake Street, make a right on Bloomingdale Road, and then go down and make a left on Bryn Mawr. So that's what we're going to use as our noble gases. Are going to be our landmarks that we use to give directions, that kind of shorten our directions. The reason why we can do that is that all the noble gases start out the same way, like the 1s2, 2s2, 2p6, as all the elements that follow each noble gas. Okay, so for example, for calcium here, calcium has the same beginning as argon. So argon ends at 3p6. So 1s2, 2s2, 2p6, 3s2, 3p6. That's the same directions as if we were giving to argon. So all this information right here is equivalent, or means the same thing as argon. And the only thing that's different about argon and calcium is that from argon, from this point here, you go to 4s2. So to see how that would look like for some more examples here, like for example potassium, potassium ends at 4s1 here. Okay, it's at number 19. So I'm going to look and see what noble gas here on the right is one that comes before number 19. Well, it happens to be argon number 18. It's directly in front of potassium 19. So argon starts out the same way as potassium. So we're going to reference it saying, hey, well, from argon, which starts out, has the same beginning as potassium, where would we go to get to potassium? So from argon, number 18, to get to potassium, you'd go at 4, energy level 4, S1. And that would be your directions to potassium, and that would be it. So that's so much nice and concise, and a lot easier to do than maybe the shorthand one, but just another way to go about electron configurations. Gallium. Okay, gallium is number 31. So what noble gas comes before gallium? Number 31. Well, we have 2, 10, 18, 36, 54, 85. Well, 18 comes before 31. 35 is 2 past 31, so we're going to reference argon again. Hey, so from argon, where would we go to get to gallium? So from argon, we would go to 4s, my pen, 4s2, 3d10, we have to go through this whole area, and then finally 4p1. 4p1 is gallium. And that would be your answer. So instead of having all this other beginning stuff here, we can just make it a little more concise. Oxygen. Okay, oxygen is number 8. The noble gas that comes before it, well, 2. 10 is way too far beyond 8, so we're going to reference helium as our noble gas here. So from helium to get to oxygen, leaving helium, we would be at 2s2. And then finally, 2p, 1, 2, 3, 4, 2p4. Okay, we'll do one more with titanium here. Titanium is number 22. So again, 18 is our winner here, argon. So from argon, you would go to 4s2, and then finally 3d2. And that would be it. All right, that is noble gas configuration.